Good evening, all. Am I audible? Tell all other students to join fastly. We have limited time. Am I audible? Can you hear me?
Yes, sir.
Yes, sir.
Okay, fine. Now we will continue the problem, second problem. So before that, we must know what is reciprocal relation. As we have already studied this relation in our metric calculations in mathematics from plus 2 onwards, you know that what is reciprocal relation. That is, a reciprocal relation states that the influence coefficient of displacement at I due to the force acting at J is equal to the influence coefficient of displacement at J due to force acting at I. അതായത് ഡിസ്പ്ലേസ്മെന്റ് ഐയിൽ ഉണ്ടാവുന്നത് ജെ കാരണമാണെങ്കിൽ അത് നേരെ തിരിച്ചിട്ടും നമുക്ക് എഴുതാൻ പറ്റും എന്നുള്ളതാണ് റെസിപ്രോക്കൽ റിലേഷൻ. ദിസ് ഈസ് നോൺ ആസ് റെസിപ്രോക്കൽ റിലേഷൻ ഓർ സിംപ്ലി വി ക്യാൻ റൈറ്റ് ഐ എ ഐ ജെ ഈസ് ഈക്വൽ ടു എ ജെ ഐ. So please take your notebooks and write the relation. It's an important relation. There's a chance of asking the same relation for at least 2 marks. Reciprocal relation. Not at all. Heading as a reciprocal relation. Subitem. Reciprocal relation states that reciprocal relation states that reciprocal relation states that reciprocal relation states that the influence coefficient the influence coefficient the influence coefficient the influence coefficient of the of displacement of displacement at I എന്നുള്ളത് quotation ഉള്ളിൽ at I due to force acting at J 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 is equal to the 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 influence coefficient of displacement 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 at J due to force acting at I at J due to at J due to force acting at I at J due to force acting at I at J due to force acting at I at J due to force acting at I. Mathematically, mathematically, Aij is equal to Aji. Aij equal to Aji. Aij equal to Aji. Aij equal to Aji. Hope you have completed this one. We will go to a problem, that is Castigliano second theorem. We have already done a problem in the same format. So now we will consider another equation. In this equation, there is a change. Here you can see that a problem of a half ring. There is a chance of misleading. Here the deflection is taken as x. So normally this is dx, that is r into d theta, and the maximum change will be 0 to pi. ശ്രദ്ധിക്കണം, ഇതാണ് ക്വസ്റ്റ്യൻ. ഈ ക്വസ്റ്റ്യനിൽ നമ്മളെ ഫിഗർ നോക്കുമ്പോൾ തന്നെ കോംപ്ലിക്കേഷൻ തോന്നും, പക്ഷെ സിമ്പിൾ പ്രോബ്ലം ആണ്. So first of all, we will write the problem. A half ring. Please write the problem. Problem എന്ന് മാർക്ക് ചെയ്യുക, താഴെ എഴുതുക. A half ring. A half ring. A half ring is fixed at one end. Is fixed at one end. Is fixed at one end. And loaded by a force P. And loaded by a force P at the other end. At the other end. At the other end. At the other end, as shown in the figure. As shown in the figure. As shown in the figure. The ring has a constant cross section. 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 And the depth of ring is very small. The depth of ring is small compared to. The depth of ring is small compared to. The depth of ring is small compared to. The depth of ring is small compared to the radius capital R. The radius capital R. The radius capital R. Find horizontal deflection delta P. Find horizontal deflection del P. Find horizontal deflection del P of the free end. Of the free end of the free end of the beam of the beam of the beam by Castigliano theorem. By Castigliano theorem. By Castigliano theorem. By Castigliano theorem. Now compare the question with the figure. You can see that as mentioned in the question, this is a half ring. So the maximum possibility of length will be 0 to pi. We know that for a circle, the maximum variation will be 0 to 2 pi. So for a half circle, the maximum variation will be 0 to pi. As well as one end is fixed and another end is loaded with a load P as shown in the figure in the horizontal direction. Okay. Now we need to find the deflection at this point itself. So there is no need of adding additional load. We have load P acting at this point and we need to calculate deflection at this point itself. അതുകൊണ്ട് തന്നെ directly we can take P. Okay. And now you need to consider a section at a distance theta. That is, this distance will be dx will be r into d theta. Otherwise, ഇതിന്റെ total deflection വരിക r into d theta. So now we have to solve the equation using Castigliano equation. So first of all, draw this figure. Please draw this figure in your notebook and tell me once you complete it. Please draw the figure and tell me once you complete this one. Have you drawn the figure? Okay, I will go to the next slide. Hope you have drawn the figure. Rakesh, have you completed the figure? Sarel, what happened to Alan? He didn't attend the last class. That's why I'm asking. What happened to him? Have you drawn the figure?
Yes, sir.
Okay, thank you. So we have a figure. I have taken this to side because I want to write something on the left side. So as we have already studied that we have Castigliano equation, that is del equal to dou u by dou p. So here strain energy is available means we can find P. So definitely you can calculate del. So this is the Castigliano second theorem. From the equation of strain energy, that is m square divided by 2e I into dx. In this equation, in the previous case we have mentioned it as 0 to L. But we know that for a half-ring the maximum range will be 0 to pi. So the range only changed. 0 to L is replaced with 0 to pi. Okay. And here dx will be dl. That is r into d theta will be dx. And after that we have to find equation of del using the previous relation. We have del is equal to dou u by dou p equal to dou u by dou m into dou m by dou p. So substituting the relation we have del is equal to 0 to pi m divided by ei into dou m by dou p into dx. We have already derived this equation in the previous case, so I am not giving much importance for intermediate steps. So you can write this equation and compare with the previous one. The only change is change in the range. In the previous case, that is 0 to L. Here, the range is 0 to pi. After that, we need to find momentum. Here, there is no chance of different momentum because whenever we are taking x here, here, or here, wherever, the relation will be p into perpendicular distance, that is r into sin theta. If we are considering here the distance is r into sin theta, then p into r into sin theta will be moment. We have studied this one from the engineering mechanics classroom. Moment will be force into perpendicular displacement. So the distance, perpendicular distance. So we have moment equation as P r sin theta. You can directly find from this figure. Very important. So look the figure and write the equation. After writing the moment equation, first of all we need to find dou m by dou p. So you need to derivative. We need to take the derivative of m with respect to p. If we take the derivative of m with respect to p, the final answer will be r into sin theta. That is dou m by dou p equal to r into sin theta. It's very simple. When we are knowing m, just take the derivative with respect to p. So the final answer will be r into sin theta. Now the another term is dx. That's already I have told that dx will be this displacement, that is r into d theta. So we can take dx as r into d theta. From the figure we need to find p and r sin theta. Then you can calculate moment m as m is equal to p r sin theta. After finding moment, taking derivative with respect to p, sorry, derivative of m with respect to p, we will get r into sin theta, and dx can be found out as r into d theta. If we substitute all these values in this equation, we have deflection equation as p r sin theta divided by ei into dou m by dou p as r into sin theta into dx as r into d theta. This will be our equation. Okay, and once completing this one, you can take r into r as r cube, sin theta into sin theta as sin square theta, and the final equation will be taking ei outside. The final equation will be 1 by ei into p integral 0 to pi p into r cube into sin square theta into d theta. Please write down. If you have any doubt, you can ask me now regarding this slide. Please understand the problem and write. Then only we can understand and write this same equation in the exam paper. Please write the equations and tell me once you complete the equation. No need of writing different places. I have mentioned it because I have only a small place for writing all these equations. So you can write according to your comfort and understanding. After this class also you need to study this page. So write in a way that is very easy to study for you. Also try to solve different equations using Macaulay methods and Castigliano second theorem. After doing so many problems, automatically you can understand these equations and learn this MOS very easily. Have you written the slide? No need to be rushed. I will ask the question. I will ask whether you have complete, whether you have complete. That's my duty. But you have to complete in a proper way. You have to write very understandably in your notebook. I will check the notebook once you reach college. Have you completed the slide? May I go to next slide?
Yes, sir.
Thank you. So the final equation of the deflection is given as 1 by EI into integral 0 to pi p r cube sine square theta into d theta. When we are taking integration, p into r cube will be remain constant. Only we need to integrate is sine square theta into d theta. You know that sine square theta into d theta, what is the integral form? And when doing that one and applying equation, we will get PR cube divided by EI into theta by 2 minus 1 by 4 sine 2 theta. Theta by 2 minus 1 by 4 sine 2 theta. Please check this derivative and if you ask me what is this, how you came to know this sine square theta, I have not much idea about this mathematics. So when doing integration, they are getting theta by 2 minus 1 by 4 sine 2 theta. And applying the limits, that is pi value in the first term and second term, the final equation will become PR cube divided by EI into pi by 2. PR cube divided by EI into pi by 2. If there are any mistake, please let me know, because even after this classroom you can contact me, because I am also having doubt in this integration. It's a specific problem. When you are doing this integration, you will get PR cube divided by EI into pi by 2. And after that, by rearranging, the final value will be del equal to pi into P into R cube divided by 2 into EI. This is the equation for deflection at the free end of a half ring whose one end is fixed and another end is free and having a load P. The maximum range of variation will be 0 to pi. That is, x is varying, radius is varying from 0 to pi. Please write down this equation. After completing, please let me know. Substituting or applying limit is very simple. When we are applying pi here, that will become pi by 2. And when applying 0, then there will be minus 0 by 2 is 0. So only pi by 2 will exist. Also sine 2 into pi means sine 2 pi, that will be 0. So there will not be any term, and sine 0 also 0. So final term only exists PR cube divided by EI into pi by 2. But I don't know sine square theta integration. This is a long process, I think. In your plus 2 classroom already you have studied what's the integral sine square theta d theta. Have you completed this one?
Yes, sir.
Okay. I will just rewind the problem. What we have done in this classroom, we have read the problem, and in this problem, after reading the problem, we have understood that there is a half ring with one end is fixed, that is shown here. This end is fixed and other end is free, and that is applied by a force P. And we need to consider a x distance. In the previous case, we have taken x distance, that is taken here, and the perpendicular distance from load, that is free end, will be r into sine theta. As we have known that if this angle is theta, definitely opposite angle will be r into sine theta. We have sine theta equation as sine theta is equal to opposite side by hypotenuse. Here hypotenuse is r, so we can write this distance as r into sine theta. It is already given, and just take a distance dx as r into d theta. After that one, we need to write Castigliano second theorem that we have already known, and after that we need to write the Castigliano formula in integral form, that is del equal to 0 to pi. That is range varying in this half thing is 0 to maximum pi value. So 0 to pi m divided by ei into dou m by dou p into dx. After that, we need to find moment, that is force into perpendicular distance, that is p into r sine theta. After that, you need to find dou m by dou p, that is derivative of this equation, that is p can be cancelled, that is r sine theta. Dou m by dou p is equal to r into sine theta. After that, we need to consider a small distance dx, that is r into d theta. Substituting this in the previous equation, that is deflection equation, m can be changed as p r sine theta. Dou m by dou p can be changed as r into sine theta. Dx can be replaced as r into d theta. By looking this equation, there are r into r that can be taken as r cube, and sine theta into sine theta can be taken as sine square theta. The final answer will be 1 by ei integral 0 to pi p into r cube into sine square theta into d theta. After that, we need to integrate this equation. For that, I am taking pr cube outside, and you need to integrate 0 to pi sine square theta into d theta, and the final answer will be pr cube by ei into bracket theta by 2 minus 1 by 4 sine 2 theta. Limits are 0 to pi. After substituting pi, this will become pi by 2 minus 0, and sine 2 theta will become sine 2 pi, that is 0, and sine 0 will become 0. The final value only will be pr cube divided by ei into pi by 2. That's the final equation for the deflection. This is the method of solving a problem or finding deflection of a beam using Castigliano second theorem. In the previous class, we have studied a cantilever beam. In the classroom, we have studied a simply supported beam. And here we have studied a half ring. So these are the different kinds of problems. And solving this last problem, we are closing our fourth chapter. So from next class onwards, that is tomorrow onwards, we will start the fifth module. Thank you for listening to the classroom, and I need the attendance. Now, please tell me your attendance. Please type your attendance in the command window. Is there any pending attendance? Means please tell me now. Alan, what happened in the last classroom?
സാറേ ഞാൻ പുറത്തായിരുന്നു അതാ കയറാൻ കഴിഞ്ഞില്ല.
Okay. The absentees are 9, 13, and 14. 9, 13, and 14. Is there any students 9, 13, and 14? Okay. In this fourth module, we have this that include Thus include deflection of beam using Macaulay's method, elastic strain energy and complementary strain energy, elastic strain energy for axial loading, transverse shearing, bending, torsion load, expression for strain energy in terms of load, geometry, material property, shearing, bending, and torsional loads, and Castigliano second theorem, reciprocal relation. Both not have required any proof. You need to study the equation alone, and we have done some simple problems related to deflection using Castigliano theorem. These are the things we have completed in our classroom. So study well, and I think you have a simple module. The fourth module is very simple for you. If you have any doubts and queries, you can ask me anytime. And if you have any queries now, you can contact me now. I want to know whether 9, 13, and 14 is available. Physics is not there. Sharin, Muhammad Sharin is not there. And Muhammad Sain Ashraf is not there. Okay, I am submitting attendance in Linways also. Thank you for listening. Thank you. Pardon. Jagesh. Jagesh, പറഞ്ഞത് കേട്ടില്ല.
ഒന്നുമില്ല സാർ താങ്ക് യു പറഞ്ഞതാ.
Okay, okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.